Asteroids are terrifyingly powerful, but they're also incredibly interesting and slightly misunderstood. Now, we tend to use the terms meteors, comets, and asteroids interchangeably, but they are very different, even though they tend to come from the same place. An asteroid is a relatively small rocky body that orbits the sun. A comet is a relatively small object whose ice can vaporize from the heat of the sun, forming what we sometimes see as that trail of dust and gas behind it. A meteoroid is a small piece of comet or asteroid. A meteor is the light phenomena from when a meteoroid enters our atmosphere and vaporizes. And a meteorite is what survives coming through our atmosphere and subsequently crashes into Earth's surface. Scientists estimate that the kind of meteorite they did here in Arizona happens every 300 years. And actually, asteroids coming to our atmosphere is quite common. Every other week, a 3-foot diameter asteroid comes to our Earth, hits the atmosphere, and then burns up. A car-sized one comes about once a year, breaks apart, and forms bolides, the technical term for fireballs. Really, any asteroid 82 feet in diameter or less won't make it to the surface. Sometimes they come close though, like in February 2013 in Russia. The giant fireball or super bolide was estimated to be 59 feet wide. Luckily, it broke apart before hitting our surface, but it was still able to blow out windows and injure over 1,000 people.
From outer space in the future. Swiss scientists have found that prehistoric meteorite fragments from Namibia can be used to make high-performing catalysts to help store energy from sources like wind or the sun. The team from the Swiss Federal Institute of Technology in Lausanne turned slices of the extraterrestrial rock into electrodes to test its effectiveness.
After taking the different slices, we removed the oxide that was formed during the cutting process, then stuck it on a glass piece for mechanical stability. And of course, we also soldered an electric wire and covered it with a non-reactive glue.
They passed an electric current through the electrodes to split hydrogen from water molecules in a process called water oxidation. This generates hydrogen fuel which can be used to store energy. It's the unique composition of the meteorite that makes it so useful, especially its nickel and cobalt impurities.
In this experiment, we observed that the performance of the meteorite was improved while performing the chemical reaction, and that is mostly due to the fact that a very active layer, a very catalytic layer, was formed on the meteorite during experiments.
So the Gibeon meteorite could hold the key to making renewable energy a cheaper and more efficient option.
In a future, eventual future without fossil fuels, we'll need some way to store renewable energy. So when it's very windy outside, we can produce a lot of wind electricity via wind energy, but if we not use that electricity right away, then we lose it. So we need some way to store excess renewable electricity in some way.
The researchers say the Gibeon meteorite demonstrates the potential for natural materials to be used as high-performing electrocatalysts in the future.